Hello, welcome to Soft Papers channel. My name is Mr. Godfrey. This is a Cambridge IGCSE Physics topical question on electricity. Exams series of October, November of 2019. In this video, I'll be taking you through these electricity questions that were set on 2019 October, November exam series. I will encourage you to consider, when you're doing your revision, waiting for your exam, especially for 2021 June and beyond, consider doing topical revision. Topical revision is key when it comes to pass. I've seen this with my students. I teach in one of the premier schools, and my students, I encourage them, I provide them with the topical questions. I need them to read their notes. I need them to read their textbook on a given topic and come attempt all the questions that will be set on that topic for a given exam series. 2019 November, 2019 June, 2018 November, 2018 June, all the way to 2016. When you do that, you are sure you'll get the examiner's mind all the key areas which the examiner sets on a given topic. And therefore, I encourage you, go to Soft Papers. The site is here, softpapers.co.uk, and you'll find these resources right there. Before continuing, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. And without much ado, I'll urge us to get started. Let's go to question number 1. Now, in every question, number 1, number 2, all the way to the number of questions that are in this paper, you'll find this. You'll find this. You'll find this in every question. This basically gives you the question number and the question paper where this question was appeared. This was question number 30. It was on variant 1, October, November. ON means October, November. 19 here means 2019. So you can always refer to the papers for any given question that I'm solving right here. So question number 1, a teacher asks a class, what quantity can be recorded in volts? What quantity can be recorded in volts? Of course, I know majority of us, we know what quantity is has got the units of volts. These are units. Okay. Now the student 1 says the potential difference across a resistor. I think that is correct. Student 2 says the rating of a fuse. The rating of a fuse is given in amperes. So student 2 is not correct, right? And then student 3 says electromotive force of a battery. I think also student 3 is correct. So which students are correct? Without hesitation, of course, student 1 and 3 are correct. And you notice that multiple choice questions are usually the papers are usually 45 minutes. Okay, so some of these questions are straightforward. You don't need to waste a lot of time on them. You read them, you get the answer, take and go ahead. And as I always tell my students, don't leave an answer, any question unanswered when the time is up, right? Just choose whatever answer, even if you are the question is not clear to you. All right, number 2. Question number 2. Question number 2 was from variant 1, question number 31. The circuit shows 2 lamps connected to a DC supply. DC supply is a battery. This kind of connection is parallel. We all know that. That's a parallel connection. And some lamps and power supply are arranged in a different way, in different ways as shown. Yeah, arranged in different ways as shown. In which circuit or circuits will the lamps be the same brightness as the original circuits? Of course, the original circuit is right here. So which will have the same brightness. Same brightness. That is the question there. Same brightness as with the one that is up there. So same brightness. All right. So you identify the circuits between P, Q, and R, which are parallel. Right? You can see P is parallel. Okay. Q is also parallel, and R is also parallel. Therefore, since there is no other electrical component in the circuit, then all the lamps will have the same brightness in P, Q, and R. So the answer here is D. Okay. Question number 3. Identical resistors, they are identical. Okay, having the same resistance, are connected together to form arrangements X, Y, and Z. Okay, we can see X is parallel, Y is in series, and Z in series. What is the correct order of resistance of the arrangement from the largest to the smallest? Now, if we take this resistor, since they are identical, let's say this is R, as our resistors R. All of them have got resistance R's. Okay, R can be anything, can be 2 ohms, 10 ohms, or so on. So what would be the resistance of Z? Since the resistors are in series, then you just add up R plus R plus R. You'll get 3R. A resistance offered by the resistors in Y will be R plus R, which will be 2R. And the resistance offered by the two resistors in X, which are in parallel, of course, will be R times R over R plus R. When there are two, of course, you use this equation. So this will be R squared over 2R. And therefore, this will be, of course, you cancel one R, you get that. So this will be 0.5 R. So then, of course, we are told that the correct order, okay, from the largest to the smallest. So Z will be greater than Y, which will be greater than X. So you look for that arrangement, and that arrangement will be Z, will be D. Number 4. This question number 4 appeared in almost all the variants, with the exception of 1, 3, 1, 2, 1, 1, 2, 1, 2, 2, 2, 3. And the question numbers wise indicate there number 34, 33, 34, 33. Where must a fuse be connected in a mains electric circuit? Where do we find a fuse in the main electric circuit? And while we are at that, what is a fuse? We know that a fuse is a safety gadget. A fuse is a safety gadget, is a safety device. Okay, it will safeguard. It will safeguard your device from excessive electricity during in an event there's an electric surge. And how does it do this? A fuse will blow when there's excessive electricity. So a fuse blows when current is exceeded. When current exceeds a given limit. Of course, the limit is usually written on the fuse, and this is going to safeguard your component. So where should it be? So a fuse should only be on the live wire. Fuse should be on the live wire. So you look at that. So the earth wire, no. The live wire only. That is correct. It should not be on the earth wire neutral. All right. or the live wire and earth wire. No, it should only be on the live wire, because the live wire is the one which is carry current. So when the current exits, it will pass through the live wire through the fuse, and the fuse will do its job. Number 5, this of course is from 1-2, and it was question number 30. Which quantity has the same units as the potential difference, PD? Of course, this goes without saying, electromotive force. Current is in amperes. Okay, we are saying same units. The unit for current is amperes. The unit for EMF is volts. The unit for resistance is ohms. And the unit for moment of force is Newton meter. So electromotive force, there is the answer. It's great you are watching this video, but remember, I always encourage you to practice work out these questions yourself as I guide you. You may get this same paper I am solving right now from solvedpapers.co.uk. This is the site I'm talking about, solvedpapers.co.uk. This is a resourceful site where you'll find all these topical questions. You'll go to IGCSE. We are doing physics. Of course, you'll find papers on 2020, 2019, all the way to 2016. We are on 2019 topicals. 2019 topicals. You'll find some topicals for 2019 for November, both multiple and structured, and solved. Of course, June we'll also get them right there. So I require you to click here. You'll be taken to this page right here, where you can find the topical questions in a zip folder. You can request your parents to help you in acquiring this. They're quite reasonably charged, £8. Of course, you'll find both physics and chemistry, IGCSE topical questions. You can still also get past paper. If you need past papers, the full past papers, you still get them here. So need you to get this, then we practice solving them together. If you need past papers, I need you to go right there also. You'll also get past papers for 2019, 2016, 2018, whichever year you need. You'll also find the past papers right there. These ones are free to download. You can download this one for free, and then you can attempt them these are past papers. You also can click here. You'll also be taken to this site. This site you can get past papers, soft past papers, right here. Okay, and you get both structured and multiple past papers. Ask your parents to help you acquire this. And that out of the way, can proceed to question number 6. A student uses 100 centimeter of resistance wire XY in a circuit to make a potential divider. Potential divider does what the name says. It divides PD. It divides PD of a cell. Okay, we have the wire here, sliding contact. Wire is connected to a voltmeter. It changes the length of wire L by moving the slider along the resistance wire. Which graphs show the voltmeter reading? Show how the voltmeter reading changes as the length of the wire L is increased from 0 to 100. And therefore, as the wire increases, as the resistance increases, voltage increases as well. Okay, so you look at the graphs. Look at the graphs which indicate increase in voltage with the increase of length. You find that graph is so L is the correct one, remember, voltage is equals to current times resistance. Now, if current is constant, if you take current to be constant, then you find that voltage is directly proportional to resistance. So when the resistance increases by increasing the length, right? Because when you increase the length of the resistance, while the resistance increases, then the voltage reading should increase, and this should be the graph. Okay, so that is the answer to question number 6. Question number 7, of course, this is number 31 from variant 1-2. A student determines the resistance of an electric lamp. Determines the resistance of an electric lamp. He measures the current in the lamp and the potential difference across the lamp. Which circuit did he use? Current through the lamp and PD across it. So the ammeter should be in series with the lamp, and the voltmeter to measure PD should be across the lamp. You know that. So you look at the two. Look at the multiple choice here. Okay. In A, you can find that the voltmeter is in series with the lamp, and that is not correct. That should be wrong. Also, this one, the voltmeter is in series. That is wrong. Here, the voltmeter is across the variable resistor and the lamp, so it is measuring the voltage across both of these. He only needs to determine the resistance of the electric lamp, and we know that resistance is equals to voltage across the lamp divided by the current that is going through it. So you need the voltmeter to be across the lamp only, and the ammeter be series with the lamp. So that means the answer here is D. The answer there is D. Number 8. Number 8 is from variant 1-2. It's supposed to be number 33. The circuit shows a wire, XY. This is XY from here to here, connected to a cell, to this cell. The PD between WX is 1.5. The voltage is 1.5. What is the meter reading? Okay, the wire is 100 meters. Okay, so we can say 100 centimeters is equivalent to resistance of the wire, and it's 1.5 volts across it. Now, when you count the divisions where the voltmeter is connected, is 1, 2, 3, 4. Of course, 100 centimeters is how many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each division is 10. All right. So then 1, 2, 3, 4. That will mean 40. So if 100 centimeters is 1.5 volts, how much is 40 centimeters going to be? And remember, length of the wire is directly proportional to resistance. The greater the length, the higher the resistance. And therefore, what we are supposed to find is the voltmeter reading. And we know that voltage is directly proportional. Voltage is directly proportional to resistance. From this equation, that voltage is equals to current times resistance. And if current is constant, then voltage will be directly proportional to resistance. Therefore, we cross multiply here. We say 40 centimeters times 1.5 volts divided by 100 centimeters. The centimeters will cancel, and when you divide nicely, you're going to get 0.6 volts. So 0.6 volts will be the reading of the voltmeter when it is connected to the wire at a point 40 centimeters in that case. Question number 9, of course, from the same variant 1-2. This was question number 35. Where must a fuse be connected in mains supply? We had looked at this previously. So it should be on the live wire. Number 10 from 1.3 variant. Number 30. A resistor is connected to a battery. There is a current in the resistor. What is the main energy change? Of course, battery stores chemical energy. So from the battery, we have chemical energy. Chemical energy in the battery. And we know that when current is flowing in the resistor becomes hot. Alright? So when the current is flowing, the resistor converts chemical energy or converts electrical energy to thermal energy. So we have, because we are told what is the main energy changes. So we have chemical energy from the battery, chemical energy from the battery, which is converted to electrical energy, which flows in the circuit. And then when it reaches the resistor converts it to the electrical energy to heat energy. And therefore, the main energy conversions will be chemical to thermal energy. There's no gravitational energy anywhere in the circuit, so that's not correct. We don't have any nuclear energy, and therefore C and D are also not correct. Number 11. This is 31 from variant 1.3. Lamps X and Y are designed to operate at normal brightness when each are connected to 3 volts supply. Lamp Z is designed to operate at normal brightness once connected to 6 volts supply. In which circuit do all 3 lamps operate at normal brightness? Which? Alright. So you can see the battery here is in air. The battery is 6 volts. And when X and Y and Z are in series, then the 6 volts will be shared between the 3 bulbs. And of course, the voltage will be 2 volts. Of course, for Z, which has got a higher rating, the voltage will be a little bit higher. So you can see none of them is operating at the normal brightness because X and Y needs 3 volts and Z needs 6 volts. So that's not correct. Look at B. The voltage here is 6 volts, and both X and Y, they are connected to, when you put a voltmeter here, this voltmeter will read 6 volts. But since they are in series, then if you put a voltmeter across X, this will be 3 volts. And if you put another voltmeter across Y, this will also be 3 volts. Likewise, if you connect a voltmeter across Z, because this Z and both X and Y are in parallel, this will read 6 volts. Therefore, the answer should be B. Of course, C is not right because the battery is 3 volts and Z needs 6 volts. So when they're in parallel like this, this will be 3 volts. If you put a voltmeter across each one of them, it will be 3 volts. And therefore, Z will not have normal brightness. So X and Y will have same normal brightness, but Z requires 6 volts to have normal brightness. Same as here. Of course, this will be, if a voltmeter is put across X, this voltmeter here will read 6 volts. So this will be way beyond the 3 volts that is required for normal brightness. This also will be 6 volts. Z will it's the only one which will be having the normal brightness here. So the answer there is B. Number 12, because you can see it's from variant 1.3. This was number 33 from that paper. Which circuit shows a variable resistor? Shows a variable resistor. Of course, you have here. This is not a variable resistor. This is a thermistor. We have variable resistor in B and C, and also this is not a variable resistor. This is a thermistor. Of course, it's a variable resistor, but here this variable resistor should control brightness, right? A thermistor controls the resistance due to the temperature change, right? So which one should control brightness? And therefore the variable resistor should control the brightness is supposed to be in parallel. Okay, this will only control brightness of this bulb in A. Will control the thermistor will control the brightness of this bulb if there's a change in temperature, but no change in temperature is mentioned in the question. So I go for B because the variable resistor here is connected in series with the bulb. So when you vary the resistance of this, you can regulate how much current is going through the bulb. And of course, when you reduce or increase the current, that will correspond to the brightness of the bulb. Okay, this is connected in parallel, and of course, since the thermistor, we are not told anything about temperature here, so that should be out. This is also connected in parallel. Well, so when you change the resistor, the resistance of this variable resistor, that will have no effect on the bulb, which is in parallel. So for variable resistor to affect the brightness of the lamp, they should be connected in series. So B is correct. Number 13. Number 13. Of course, number 13 is from variant 2.1. This question number 28. A circuit contains a cell of electromotive force 2 volts. The current in the circuit is 2 amperes. How much energy is converted by the cell in 2 minutes? Energy is given by multiply the voltage times current times time. Time should be in seconds. So voltage here, of course, converted by the cell. How much energy is converted by the cell? So we are talking the EMF of the cell, which is 2 volts, times the current, which is flowing through the cell, which is 2 amperes, times 2 minutes. But you have to change that minutes to seconds by multiply by 60. Therefore, when you multiply all those, you'll get 480 joules. So answer D. Number 14. Of course, this is from variant 2.1, and this was number 29. The circuit diagram shows a cell connected in series to a resistor and a component X. What is component X? Of course, this component X here is a diode. Of course, a bell, the symbol for a bell in a circuit looks like this. Symbol for an heater in a circuit looks like this. This is how the symbol of a heater looks like. And of course, a thermistor looks like this. This is a thermistor. But of course, then this is a diode, which is shown right there. So the answer is B. Before we go to question 15, I'd like to welcome you to join me in my online classes. I have online classes where I do tuition. If you need any assistance in physics and in chemistry, you can always get me in my online classes. We have a site we call spacademy.co.uk. You can have a look at it. This is where we do our online classes. We help students from all over the world. So If you need help in tuition, get in touch. This is the site I'm talking about. SP Academy is basically Soft Papers Academy. This is our site. You can have a look at what we offer in this site. It's a wonderful site. I need you to click here to look at a step-by-step guide for students, dashboard functionalities. When you sign in, you have your own dashboard where you can book a lesson, book a class, and so on and so forth. You also can watch this video to get familiar with our online live classes. So I need you to get to this page, log in. Here you can register, sign up, and discover. You can sign up here as a student or as a tutor or as an instructor. Of course, you need to give your credentials. You create your own account. We'll send you an email where you need to click to activate your account. Then you can join. You can sign in. So you must supply the correct email because you'll need to activate your account. We'll send you an email to activate your account. So once you have signed in, then you can search for a tutor of your choice. We have tutors available to help you. Here we have the tutors right here. And then of course you can tell them what course you need. We have a lot of courses here. Of course, you tell them where you are from. We teach students from all over the world. Okay, so you tell them which part of the world you are. And then of course we also do this. We teach UC online BBB, which is basically like Zoom. So welcome to my online class, and I will help you get your outstanding grade as you desire. Hope to see you. Right, number 5. If I can just let me just remove this. Let's go to number 15. Sorry, number 15 is from variant 2.1. Variant 2.1 of October 2019. This is number 31. A circuit contains a cell of electromotive force 2 volts, 3 resistors, 3 ammeters, and 2 voltmeters. One ammeter is labeled P, this one here, and 1 voltmeter is labeled Q, this one here. The reading on the other 2 ammeters, and the other voltmeters are shown. Of course, this ammeter is 2 amperes, and there's another one. We have 3 ammeters. Where's the other ammeter? We have this and this, and then this one, 0.5. This one is not shown. So what is the reading on ammeter P, and what is the reading on voltmeter Q? So ammeter P is going to have the current. We see the current coming here is 2 amperes, go through this resistor, but when it reaches here, it divides out. Some current go this direction, the other go this. So in this ammeter, we have a current of 0.5 out of the 2 amperes. So how much current is going through P? So of course P, the current in P will be 2 minus 0.5, and therefore the current in P will be 1.5 amperes. What about the reading on voltmeter Q? Of course, we say that P is 1.5 amperes. That will be the reading. What about voltmeter Q? Now, of course, in voltmeter Q, we are told this is 2 volts, and therefore you can see here the voltage across this resistance is 0.5. And if the voltage across this is 0.5, if you put another voltage here, if you put another voltmeter here, not voltage, another voltmeter here, this voltage of this voltmeter will be the same as the voltage of this voltmeter, will be the same as the voltage of this voltmeter here, because they are in series, right? Sorry, they are in parallel. Okay, so to get the voltage of this voltmeter will be the difference of 2 and 0.5 volts. These are volts, so this will be 1.5 volts. So this voltmeter here will be will be 1.5 volts, same as this one here, 1.5 volts, and this one here, 1.5 volts, 1.5 volts. So you look for that in the multiple choice, and therefore you'll find the answer is reading for P will be 1.5, the reading for Q will be 1.5. So the answer there is A. Number 16, which is from 2-1, question number 34. We are told that a student investigates the output voltage induced across a coil of wire by a bar magnet. Of course, when will the induced voltage have the greatest value? Induced, this is how alternating currents are produced. A magnet moves within a coil, or a coil moves inside a magnet, and therefore EMF is going to be induced. So the induced voltage is directly proportional to the rate at which you turn the magnet. And therefore, you look at, because you're told the student slowly moves, that will not be a great voltage produced. The student leaves the bar magnet stationary. No voltage is induced unless one of them is moving, or either the coil or the magnet should be moving. The student quickly removes the bar magnet from the coil. That will be it. Quickly means that a great voltage will be induced. So C is correct. The student places the bar magnet at rest, so no voltage there will be induced. So slowly will induce small voltage, but stationary and rest, no voltage will be induced. Question number 17. Of course, this is from paper variant 2.2, question number 9. There is a current of 2 amperes in a resistor for 30 seconds. The potential difference across the resistor is 12 volts. How much energy is transferred? Of course, say that energy is equals to voltage times current times time. Time in seconds. Of course, that is in seconds too. So 12 times 2 amperes times 30 seconds. And this will give you 720 joules. So the answer there is D. Number 18. Number 18. From variant 2.2, this was question number 31. Resistors of 1 ohm, 2 ohm, 3 ohm are connected in parallel with a cell. What statement is correct? Right? Of course, when you connect them in parallel, of course, for instance, this is parallel. These 3 resistors are in parallel with a cell. Connect in parallel with a cell. Let's just draw the cell here. Okay. This is the cell right here. And this is 1 ohm. This is 2 ohms. And this is 3 ohms. What statement is correct? The current in each resistor is different, but the potential difference across each resistor is the same. That is correct. Without even going to the other multiple choice, because the more current will pass through resistance 1 ohm because it's offering least resistance, and less current will flow through resistance 3 ohms because it is more resistance. Then of course some current between what is flowing in resistor 1 and resistor 3 will flow through this, but the voltage, the PD across each of the resistor is the same, because when you connect a resistor here in parallel to the volts, this resistor will give the same voltage as the one which is given by the cell. So if you connect individual voltmeters across each resistor, will be having the same reading. So that's why it's correct. The rest usually can still go through the rest. The current in each resistor is the same. That is not correct. The potential difference across 3 ohm resistor is greater than the, no, that is not correct, because the voltmeter is correct, is the same. The sum of the potential difference across each resistor is equal, no. If you add the sum, it will be 3 times the EMF of the cell. So those are not correct. Numbers 19. The diagram shows circuit simple. What is it used for? Of course, this is the diode. What do we use the diode for? A diode allows current to flow only in one direction. Is a directional resistor. We call it a directional resistor. In one direction, the resistance is very little, so the current will flow through. But in the opposite direction, the resistance will be almost infinite, and therefore the current will not go through, right? So diodes allow current in one direction only. Question 20 goes from variant 2-3. This was question number 28. There is a current of 3 amperes in a resistor for time t. During time t, the charge, this flows through the resistor. What is time t? Of course, you know that the 3 quantities, charge, current, and time, are connected by this equation. Charge is equals to current times time. Therefore, we need time. We make time subject. It's going to be current divided by, charge divided by current. Charge is 120 coulombs divided by current, which is 3 amperes. And therefore, you'll get 60. And 120 divided by 3 is 40. So 40 seconds. Time is in seconds. So the answer is 40 seconds right there. Number 21, of course, from paper 2-3, number 30. Resistors of resistor, this are connected in parallel across a terminal, right? Which statement is correct, right? The current is in the resistor is equal. No, we'll have more current passing through the resistor that is offering least resistance, and less current in the other, which is offering more resistance. So it's not equal. So this is not right. The sum of the currents in the 3 is equal to the current in the cell. Yeah, that is correct, right? Can demonstrate that by drawing small circuit here, right? These are in parallel. These are 3 resistors in parallel, and this is the external circuit. So the current flowing through here, if it's I, this I will be, this is I1, this is I2, and this is I3. Then I will be equal to I1 plus I2 plus I3. That's why we say the sum of the current in the 3 resistor is equal to the current in the cell. Of course, if that is B is correct, then the rest are not correct. C and D are not correct. Question number 22, of course, was from variant 2-3. This was question 31. Diagrams 1 shows circuit containing an AC power supply, right? This is how we show AC, the symbol of AC, an unknown component X, and a fixed resistor. This is a fixed resistor. Diagram 2 shows how the potential difference across the resistor varies with time. If you connect a voltmeter here, right, then you take the readings of voltmeter with time, then this is the PD, how it will vary. What is component X? Now, component X seems to be, because for AC, if you are told the power supply is AC, for AC, the current, the graph of PD with time should be a sine graph. It should be looking like this. It should be a sine graph. should be a sine graph like this. But you can see the component X is cutting the reverse current. This is in one direction of current. This part is in opposite direction. So it appears component X is blocking current flow in the opposite direction. It's only allowing current to flow in one direction. That's why the PD time graph looks like this. And the only component that can block current to flow in one direction is a component that has got a very high resistance in one direction, but it has got very low resistance in the opposite direction. And therefore that component can only be a diode. A thermistor basically is temperature dependent resistor, does not depend on which direction current is flowing. A relay is an electromagnetic switch, also does not block current in whichever direction. And a light dependent resistor is one that is going to vary due to light intensity. So the only component that will block current in one direction and allow the rest in one direction is the diode. So that's it for this electricity paper. I urge you to get the rest of the topics from solved paper, this site here, from solvedpapers.co.uk. Practice working out these questions, and you'll find yourself in a better position to score a good grade come next exams. Thank you very much for watching this video. See you in my next video. Bye.